Hi everyone, I'm Mr. Gods, God with honor mathematics solutions. So please let's consider the next interesting logic question, and that's logic question 15. The question says the fourth and ninth terms of an arithmetic progression are -3 and 12 respectively. Full stop. Say find the common difference. Okay, so this question, as a matter of fact, is being said from what the topic we call AP and GP. That's arithmetic progression and geometric progression. Okay, and you can see the question required us to find the common difference. And AP is a kind of sequence that involve what we call, first term and common difference. So how is the terms of the sequence of AP generate or being generated? So to generate the sequence of AP, there's need for us to get the first term, and also for us to get what we call the common value, which is also called common difference. So to generate the sequence, the terms of sequence, so the common value will be added to the preceding value to give you the next value, and that is how you continue to generate the terms of sequence of AP. And if you want to go back, it's a simple calculation of subtracting the common value, that is that common difference, to take you back, okay, or the preceding value. So that does it. It's either you add or you subtract of that common value. So that does it. But now, nothing like the terms of sequence here. There is nothing like terms. This is what I mean. Let's assume 2, 4, 6, 8. You know that looking at this, these are the terms. So this is the first term, which could be represented as A. For you to get the second term, you discover that there's a common value, and that could be 2. 2 plus 2 will give you 4. 4 plus 2 will give you 6. 6 plus 2 will give you 8. And if you want to come back to 6, you subtract that 2 to give you 6. You subtract 2 to give you 4. That is what I mean, right? Now, but these kind of terms, they are not given here. And that is what, and the common value, which, have been adding to give all this, is not also given. Then, and that is what we're asked to calculate. Okay? So see how we resolve this kind of problem, in which the terms are not given. But meanwhile, you can see that they say the fourth and the ninth terms of an arithmetic progression are this. So for us to resolve this kind of problem, then you have to, apply the n term formula. And you now say from n term, you use this one to represent, which is what? A plus, open bracket, n minus 1 d. So take note. So this is the formula for calculating, the n terms. This is the formula for n terms. Okay. Now what do we do here? A stands for what? The first term. N stands for the what? The position. The position that that holds the value. Okay. Then D, which stands for that common difference, right? So without waste of time, since they mentioned fourth, you now start by saying this is fourth equals to -3. Then they also mention ninth. So you now say ninth equals to what? 12. Right? Now from this, the fourth and the ninth, then you can now substitute it into this very formula. This is what I mean, which implies, let me say that, then the fourth term implies this is a -3 equals, so wherever you see Tn, just write -3 there, equals to A plus, then you can see the n. The n there is the what? Is 4, which is 4 minus 1 d. Okay, so which implies -3 equals to A plus, then 4 minus 3 minus 1 will give us 3d. Okay, that is 3 times d. You give this one as equation 1. So also let's consider this, which is T9, which implies, what is the position of T9? That's the ninth position. The value, yes, on the ninth position is 12. You can see that is 12. equals A plus, then you can also see, then the 9 will come here, minus 1, then D. Okay, which implies that is 12 now, equals to, this is A plus, then 9 minus 1 will give us 8. 8 times D will give us AD. 8D. So you give it as equation 1, right? Equation 2, please. Then you have to solve the equation 1 and 2 simultaneously. Okay? You solve equation 1 and 2 simultaneously. As you can see, this is equation 1 and this is equation 2. What are we looking for? We are looking for D, which stands for common difference. Okay? So let me say solving simultaneously. Solving simultaneously. Okay, so what I mean is this. I have to rewrite it again. That is the first one, which is equation 1. I can say A plus 3D equals to minus 3. Okay, it's still equation 1. And the other one, which is this, A plus 8D equals to 12. This one is equation 2. Okay, now mark you, we are looking for what? D. For us to look for D, then applying what? Elimination method, then I have to make sure that, this and this, they are the same for me to cancel it. And looking at it, they are the same. That is A and A. Then you do something like this. Then you subtract. So what am I going to do now? Let me say I'm subtracting equation. I want to subtract equation 1 from 2. Listen to me. I'm subtracting this equation 1 from 2. If I'm subtracting equation 1 from 2, it's assumed that this is A minus A will cancel itself, right? Then this is plus, Matthew, this is 8D minus 3D. 8D minus 3D will give us what? Give us 5D equals, then this is 12. 12 minus, look, 12 minus, because I'm subtracting this from, I'm subtracting equation 1 from here. So 12 minus, okay, minus will change to plus, right? So that is 12 plus 3 will give us 15. So here is 15. So that does it. Now you have to divide through, okay, by the coefficient of D. So which implies this is 5D all over 5 equals to 15 all over 5. So therefore now D equals to what? 5 into 15 will give us 3. And the 3, that stands for the common difference. That stands for the common difference, this 3, because we are asked to find the common difference represented by what? By D. So it's no more than this. You can see how we resolve it. So it takes a little bit, process, but it's still very simple. So viewers all over the world, if this logic question and the solution is interesting, please continue to subscribe into my YouTube channel. Bye and for now.